Hello guys, and welcome to this new tutorial of M42, also known as the Orion Nebula. Before starting with this tutorial, I would like to give you a piece of information on this image that I'm going to show you in just a moment. This is an image created with a Vaonis Vespera Pro, which is an amazing smart telescope. And it is the result of a total exposure time of 9 hours with a single exposure time of 15 seconds for each image. All these images have been stacked by the telescope itself, and it delivered a very high quality file in a TIFF format that you can put inside PixInsight and start your editing. Another very interesting thing is that on the Vaonis Vespera Pro you can also set the gain level of your image sensor, and in this case has been set to 18 decibels. And it's also important to notice that this image has been shot under a sky that has a very low level of light pollution. And more precisely, it is a Bortle 2/Bortle 3 skies. So you don't have many background gradients in this image. I would like also to tell you before starting that I'm going to divide this tutorial in two parts, as it's easier for you to follow the editing process. This part is going to deal with the linear stage of the image, that is to say from the beginning to the stretching procedure, whereas the second part of the tutorial will deal with the non-linear stage of the image. For this tutorial and for the upcoming tutorials, you will also need some scripts. I will put the link in the description of this video. You have to go to Resources, Updates, and click on Manage Repositories. These are the links, just ignore the first links, and these are the links that allows you to download very useful scripts that will elevate your editing process. So it's very important that you download them. So let's start by the first step we are going to take is to stretch the image, because the image that you see is pretty much dark. So you have to open the ScreenTransferFunction right here, and since this is an image that has not color calibrated, hasn't been color calibrated yet, you have to unlink this little chain icon. That is to say, unlink the RGB channels, and then you auto stretch the image. Don't worry if you see like a little bit of green in your image or very weird colors, because we are going to deal with the color calibration in just a moment. So after auto stretching the image, I use the BlurXTerminator tool, which is a tool from RC Astro, a very, very useful tool. As a first step, I check the correct only option, as this allows me to correct any slightly elongated stars. I don't see elongated stars on this image, or at least at the very corners I can see like a little bit of elongation in some stars, so I'm going to apply it regardless to my image. Okay, this process sorry, will take a while, so take your time and let's see the result. Okay, let's wait a little bit. You can also, if you want, you can skip this the processing loading time and to get to the result directly. Okay, let's wait a little bit. Okay, it has almost finished. And the process has been completed. Okay, after correcting the elongation on the stars, sometimes I also like to correct the very bright stars that may seem a little bit how can I say it? They look a bit bloated. So you have to reset the settings of your BlurXTerminator and bring down the sharpen non-stellar to 0. I don't usually sharpen my nebula at this stage of the editing process because it can introduce many unwanted artifacts on your background especially. So you just leave the sharpen stars to a value of 0.5. You can also lower it down a little bit to a value of 0.3. Let's drag and drop the process on our image. Sometimes the sharpen stars delivers very good results, excellent results, whereas in other images, especially with a lot of faint nebulosity, for example the Rosette Nebula, you may notice some dark halos appearing around your stars after applying the sharpen stars. If this is going to happen, just don't apply the sharpen stars. We can shrink the stars later, and in the second part of the tutorial I will show you how to do it. I think that in this image the stars look pretty fine also with the sharpness applied, so we can close BlurXTerminator and we can go on with our tutorial. Now, what do? I usually remove the background gradients using the dynamic background extraction, which is a very powerful tool that gives you a very fine control on your image, unlike many other automatic background extraction tools that sometimes don't work so well on all of your images. In my image I don't see a lot of gradients, but I am going to apply it regardless in order to show you how this tool does, how this tool works. So you have to click on your image to activate the DBE, and I usually set a tolerance level of 2.5. I put a value of 6.0 in the shadow relaxation, and I click in the sample generation tab. I click generate. This is going to generate some many sample points on your image, but I think that those sample points are just too small, so I'm going to increase the default sample radius to a value, for example, of 60. It depends on the image you're dealing with. You have to use a different value just to have a bigger sample points. So I'm going to click resize all, and the most important thing you have to keep in mind is that you have to keep all these points away from your main nebula. It's okay to put these points in the faintest regions, for example here, this dark region, this area is not good because you don't want um to alter the structure of your nebula. Let's move this point right here, maybe this one here. Okay, let's move this here. And you also have to avoid very bright stars, otherwise you will get very weird results after your dynamic background extraction. So try to set the sample points to the very dark regions of your image. Okay, take your time because this is a very important step if you have if you're shooting from a very light polluted area. Okay, and it seems pretty fine. You have to go then to target image correction and set the correction method to subtraction and check the normalize option. Then you just have to apply your dynamic background extraction, and let's see the result. First of all, we have to take a look at the background model by auto-stretching it and activating the 24-bit lookup table. Okay, this way you can see the gradients in a smoother way, and as you can see in the corners of the image there are a little bit of gradients. Let's take a look also at the image, so let's auto stretch it, and I think it's pretty fine. So discard the background model as you don't need it, and the thing I am going to suggest you is that you should save this dynamic background extraction window. This will save the points, the sample points that you placed in your image. In order to do so, you have to drag this triangle icon on your workspace, and this will create a copy of the process. You can now close the DBE extraction window, and you can reduce to icon the original image, as we are going to work only on the DBE image. I'm going to rename this image just as DBE by, of course, double-clicking the name tab of your image and click OK. After dealing with the gradients, we have to color calibrate the image. But before color calibrating the image, we have to image solve you have to image solve your image. This is going to tell to PixInsight which DSO you're dealing with. So you go here on Script, Astrometry, and Image Solver. In the Image Solver tab, and this is very important, otherwise you won't be able to image solve correctly, you have to set the pixel size and the focal distance of your smart telescope. In this case, the Vaonis Vespera Pro has a pixel size of 2 microns, and the focal distance is 250 millimeters. As you can see, if you click here on resolution, it is going to give you the correct resolution of 1.65 arcsec pixels. After this, you have to click on search, and you have to, of course, search your DSO. In this case, we are dealing with the M42, so let's search it, and as you can see, you may have different names. It's fine to click the first one, the Great Orion Nebula, which is the old name of the Orion Nebula. Let's click OK, and again OK, and then yes. This process is going to take a bit. And for this purpose I am using the offline Gaia DR3 databases that you can download from the PixInsight, from your personal area on the PixInsight website. This is just to avoid to download every time in a temporary way the Vizier database. Okay, let's see if it's going to image solve correctly, but I think yes. Okay, let's wait it. Okay, it should finish in a moment. Okay, and the image solve is completed. Now you have to color calibrate your image using the SpectrophotometricColorCalibration, also known as SPCC. A very important thing is that many people don't like to apply the dynamic background extraction before the spectrophotometric color calibration, and they apply it after the SPCC and after they have removed the stars. But personally, in my opinion, I think that it's better for you to remove the gradients, because if you apply this, the SPCC with the gradients in your image, you're basically coloring your gradients. So in the SPCC window, since this image has been shot using the ARCAT filter, you have to leave in the red filter, green filter and blue filter the Sony color sensor UV ARCAT. If you're shooting with a light pollution filter, which is the dual band filter, you have to use different settings, but we will see this in another tutorial on another DSO. So a very important thing to do is to tell SPCC which one is the real background of your image in order to make a correct color calibration. For this purpose, I'm going to use a very useful script from SETI Astro, which is the find background. You can find the link of the repository in the description of this video. So let's open find background, which is very easy to use. You just leave the default settings and click on search. This is going to statistically look the best area of your image that may be the real background of your image. So let's close this script and let's take a look at the background area. And I think this is just fine. This could represent the real background of your image. So you have to now select the region of interest. Basically, you have to say to the SPCC which one is the background. Okay, then click OK and apply the color calibration to your image. This is going to take a while as well. Let's wait a little bit. And it's done. Okay, you can close this window as you don't need it. And let's auto stretch our image, but this time we have to link the RGB channels. Let's auto stretch the image, and as you can see now the colors are super good, very pleasant, and basically they are the true colors of this region. So let's close the spectrophotometric color calibration window. and let's also remove this background area by clicking the delete preview button right here. After color calibrating your image, you have to basically remove the stars. You can remove the stars by using many tools. There are many options that you can choose. For example, I usually use the StarXTerminator tool. You can use the StarNet. Sometimes StarXTerminator is going to give you a better result than StarNet, and on some other images the StarNet is going to deliver a better result than StarXTerminator. Okay, let's open StarXTerminator, and I usually check generate star image, and since this is a pretty much wild field, I check also the large overlap options, considering that we also have very bright stars next to the Orion Nebula. Okay, let's apply the StarXTerminator tool, and let's wait for it and to see if the result is pleasant. Again, you can skip this processing waiting time to see the result, and hopefully we will get a very clean image. So let's see. Okay, halfway. Okay. And it has almost done. So let's see the result. Okay, and I think that the result is very, very good, very clean. You can still you can see some areas that haven't been removed, some stars that may be still in the image, but I think it's fine. We can leave it like that. You have to reduce to icon the star image. On the second part of the tutorial, I will show you how to deal with stars, how to shrink stars, and I will show you a very interesting script. You can also close the StarXTerminator window, and now we have to apply the NoiseXTerminator. We basically have to denoise the image. On the Vaonis Vespera Pro, the noise level is not so high. It's a very fine and subtle noise, which is very pleasant. So I usually use a value between the noise intensity between 0.55 and 0.65. I also check the intensity and color separation, as I want also to remove a little bit of noise color from my image. So I think these values should be fine, and let's drag and drop the process on our image. The biggest mistake you can do with your image is to completely remove the noise from your image. This is something that you shouldn't do, because Noise contributes to sharpen. So in the very faint areas of your image, if you completely remove the noise from your image, you'll probably end up with very muddy looking images. So just go easy on the noise removal, and I think this result is pretty fine. As you can see, we still have some level of noise, and it's a very pleasant noise. So we have to close now the NoiseXTerminator, and now it comes the most difficult part of this tutorial, because we have to deal with the stretching of Orion. Since Orion has a very bright core and a very faint surrounding nebulosity, you have to stretch the image in small steps, and I will show you how to do it. So first of all, you can close the screen transfer function, as you don't need it anymore, and you have to reset the STF auto stretch by clicking this icon right here. As you can see, if you zoom on the image, the core of Orion is showing in an amazing way. Of course, there are some areas of the image that are a bit burned. I suggest you that when you shoot Orion, you set an exposure time of maybe 10 seconds or even more, just to get better details on the core of the Orion Nebula. Okay, let's start with the stretching procedure. You have to open histogram transformation. Click on the preview window, and what I'm going to do is to brighten just a tiny bit the core of this nebula. Of course, you always reset the settings on the histogram transformation, and just take this midpoint a little bit on the left. I think this level right here of stretching is just fine on the core. Let's see the before and the after, and as you can see, the core is still looking very good. We have a lot of color information there, and we can apply the this process, reset the histogram transformation tool, and leave it open, as we will need it in this procedure. Close also the preview window, and now we have to create a range mask using the range selection tool. This is because we want to protect the core of the Orion Nebula and just target the surrounding area of Orion. So let's open the preview, and let's apply the screening method. This method is really important, because when you create a new mask, the screening method is going to smooth out your mask and make it more gradual, so you will get a more natural result on your processing steps. Let's also introduce some smoothness on the mask, just to smooth out the edges of our mask. Let's apply it, and don't close the range selection. Close the preview window and apply the mask by dragging and dropping the name tab of the mask under the name tab of your image. Under the name tab of your image. Okay, now you see a pretty much red image, and this is the area, like the red color is the area that the mask is protecting. Since we want to protect the core, we have to invert the mask. So you have to go here and click Invert Mask. Okay, now the core is red, and this means that this area right here is protected. So let's go again on histogram transformation, open the preview, zoom on the core, and just stretch a tiny bit. Okay, I think this is just fine. Apply it. You have to repeat this process over and over again. Okay, let's close the range mask and let's create a new range mask. This time is a little bit bigger. Okay, let's open again histogram transformation. Okay, let's apply the mask to our image. Okay, always remember to invert the mask. Okay, let's reset the settings of histogram transformation. Always zoom on the core just to have a better view, and again stretch the image a little bit more. As you can see, you're keeping the information on the core of Orion while stretching the surrounding areas. So apply the stretching, close the preview, close the mask, create a new range mask. Okay, and apply again the range mask to your image and invert it. Let's open the preview of the histogram transformation. Let's reset everything and zoom on the core. Okay, we can stretch it just a tiny bit. Go easy on the stretching and take your time. You can also see the before and the after, and I think it's looking sweet. Okay, let's close the real-time preview, let's close the mask and create a new range selection. Each time the range selection will be bigger, and this means that you're doing the right procedure. Okay, let's apply the range mask and invert it again. Let's open the histogram transformation, let's reset it and zoom on the core. Okay, let's stretch it a little bit. Okay, you're starting to see also the Running Man Nebula, which is good. Let's see the before and the after, and I think it's looking pretty fine. Okay, apply it and reset the settings, close the range mask, create another range mask. Okay, and apply the range mask to your image. Okay, let's go to let's open the preview and let's zoom on the core. Okay, let's stretch it. Okay, now you see more nebulosity on the Running Man Nebula. Okay, apply the stretching, close the preview window, close the range mask, and we can try to create just another range mask to see if we can stretch a little bit more. Okay, apply the range mask and invert it. Okay, open the preview, zoom on a bigger area, and let's stretch a bit more. As you can see now, you notice the faint nebulosity appearing. Okay, don't stretch it too much. I think this level is just fine. Okay, apply the stretch and reset the histogram transformation. Now you can close the histogram transformation, close the preview, and of course close also the range mask. We are going now to use another method of stretching, but before we have to create another range mask targeting only the new visible areas. Okay, as you can see, this is a pretty easy stretching method. It just takes time. Invert the mask. Okay, and now let's open the generalized hyperbolic stretch. Okay, let's open the preview window, and here we are. Okay, here we have to first set the transformation type to linear. In this transformation type, we have to first of all delete all this dead space that you see here between our curve and this indicator right here. So you have to move the cursor very near to your curve without touching it. You click and this line will become yellow. After this you have to send to BP, okay, and apply the change. Now you have to reset your GHS, which stands for Generalized Hyperbolic Stretch. Okay, and we are going to play a bit with the stretch factor, the local intensity, and the symmetry point. Let's see, for example, if we boost the stretch factor, the brighter areas will become really, really bright, as you can see, and you're starting to lose information on the core. So you can lower down the local intensity. Let's use, for example, a -2.6 maybe value, and try to increase the stretch factor. Maybe I can bring it to 9.2. Okay, 9.290. Now we can see if altering the symmetry point will bring better results. Okay, if you move the symmetry point too much, it is going to clip on the black point. We can set maybe the symmetry point to, okay, let's see. Okay, maybe to 0.012. Okay, let's see the before and the after, and as you can see now the image is more visible on the fainter areas. you can apply these settings right here. Now you have to reset the settings, close the preview window, and you can close your range mask. We are going to create another mask. Okay, so as you can see now on the mask, you can really notice the fainter areas of your image. So create this range mask, okay, and apply it to your image. Always invert the mask. Okay, again, on the generalized hyperbolic stretch, open the preview window, and we can try to increase again the stretch factor, maybe to show more the surrounding nebulosity. Let's reduce the local intensity, as we don't want to blow up the core of the Orion Nebula. Maybe a value of minus 2.3 is good. Let's move also the symmetry point, maybe to, okay, 0.14. I think this is looking very good. Okay, the core stayed pretty much the same, as you can see here. Okay, we have a better view on the core. This is the after and this is the before. As you can see, the information is pretty much retained on the core. Okay, now you have to remember to apply your generalized hyperbolic stretch. Okay, and you can also apply another round of generalized hyperbolic stretch. Okay, this seems pretty good to me, so we can try to apply it one more time. Okay, let's close this window. Okay, let's close the real-time preview and let's remove the mask we applied. Now I'm going to try a tool that is called masked stretch, in order to stretch also the fainter areas of the image. Sometimes it can deliver very good results, other times you just have to proceed with the GHS until you find a very sweet spot for the Orion Nebula. I will keep this time this mask because I would like to see if applying the masked stretch without a mask applied is going to deliver a good result, and I would like also to see if applying the masked stretch with a mask with a protection mask applied is going to deliver a better result. So you go to Process, All Processes, and open the masked stretch. Okay, here you just have to drag and drop the triangle over your image and just wait a bit for the results. Let's see if this is going to give us a good result. Then if the result is not good enough, we can try with a protection mask applied. So let's see. This is going to take just a little bit, so you have to be patient. Okay. It has almost finished. Okay, and it's done. As you can see now, The faint nebulosity is just amazing. Just wow. And the core is a bit brighter, but don't worry, because we can apply a very interesting tool that I'm going to show you in about a moment, that is called HDR multiscale transform. We will see this on the second part of the tutorial, and thanks for watching, guys. And if you like the video, just click like and subscribe to my channels. Here you will see many upcoming tutorials, also on the Vaonis Vespera Pro, and you will learn new tricks to elevate your editing skills.